So this is Unit 3, Lesson 5, Evaluating Logarithms. Remaking the video, might cut out last time, but that's how it goes. But this will be a little bit faster because there's nobody in here but me. So in the last lesson, we compared the graphs of y equals 2 to the x and y equals log of 2 of x. And we learned that basically that the exponential comparison to a logarithm with a similar base is going to be the inverse. And we graphed that, and we looked at their graphs and how they were reflected across the y equals x line, which again proves to us, along with our thinking previous units, is that that's going to be the inverse. So with that being said, we need to get good at being able to go back and forth between log and exponential and knowing how we can write logs as exponentials. And so if we just evaluate this logarithm here in terms of converting to exponential form, Kelsey was asked to evaluate log 2 of 8. So she's evaluating that is a value. So log base 2 of 8 kicks out a number. And so it is still the reverse thinking, because if you're already getting used to it, you'll notice that whatever it equals, if I wrote an exponential form, would be the exponent. Well, what do you mean? Well, that's what they have written here. So it's 2 to the v equals 8. So wrote in exponential form. And then we kind of tell ourselves, like, okay, well, it was wrote in exponential form. So what 2 to what power is 8? Well, that'd be 3. Okay, but we're going to go ahead and just do the common base step. Okay, because we know the answer is going to be 3, but we'll get a common base of 2. So we write 8 as a power of 2, so 2 cubed. And therefore, we can compare the exponents because they have the same base. And so v equals 3. Therefore, the value of log base 2 of 8 is 3. And that's the process we're kind of going with today in terms of evaluating. Now, you're able to use your calculator for some of these things, but when it comes to solving stuff later, you don't want to be too calculator dependent. So make sure that you don't get in the rhythm of only just being able to do it in your calculator, which some of you gravitate towards, since that's obviously sometimes easier. But in terms of, let's go through some examples here. And again, I'm not using the calculator here. We're evaluating these by hand. So log base 3 of 81. So we're going to write, again, we're going to set this equal to v. So that means 3 to the v equals 81. 3 to the v equals 3 to the 4th. V equals 4. Therefore, log base 3 of 81 equals 4. Just kind of go through that whole process that we just wrote down from what Kelsey did up there. Okay, I'm just going to zip through these for you. You can pause the video if you need it to slow down. So we got log base 4 of 64. So we're going to go ahead and put, again, v. V is an arbitrary variable. You can make it x if you'd like. You can make it different stuff like that. Honestly, I'm not sure why they chose v, but I'm just staying with that. So 4 to the v equals 64. 4 to the v equals 4 cubed. V equals 3. Log base 4 of 64 equals 3. Okay. This one's going to be kind of, these two are going to be proofs that we're going to have here in a second, but we'll go ahead and do these anyways. So we know it's going to be equals v. 7 to the v equals 7. Okay, remember this 7's already got a base of 1. Excuse me, not a base of 1, a base of 7 with an exponent of 1. So that one's already ready. V equals 1. So therefore, log 7 of 7 equals 1. Okay, and you'll see, we'll talk about this in a second. A base of the same number is always going to be 1, and we'll show you why. Okay, and this one's a little bit different because we're going to go ahead and say, okay, well, 12 to the v equals 1. Well, I can't change 1 to a base of 12, really. We just have to remember anything to the 0 power is 1, right? So that would be the case there. So anytime you have a 1 here, the output over here is going to be 0. Okay, it doesn't matter if it's a 12, a 5, a 20. It's going to be anything to the 0 power is 1. So then it'd be log base 12 to the 1 equals 0. Okay. All right, good. Let's go ahead and talk about those last two here a little bit more in depth. So determine the value, and we're kind of setting up the definition right now. It's whether you're using a letter b there. So log b to the 1. So that means we're going to, if we call this v, it'd be b to the v equals 1. Therefore, v has to equal 0. So anytime you're doing a log b to the 1, where there's a 1 there, your output will be 0. Okay, that's what you're figuring out. So you would just write log b to the 1 equals 0. And so the important thing is this is going to change, right? The 1 is what signifies the 0, and that's going to be an every time type thing. Okay, then if we switch over here to the other one, log b of b. Well, log b of b, so that's a b to the v equals b to the 1, so v equals 1. So every time log b of b equals 1. And so the thing to point out here is whenever these two numbers are the same, the output's a 1. Log 10 of 10, okay, log 11, 11, log 7 of 7 before, etc. Okay, let's go ahead and finish a few more of these here. We have to get a little bit more into our exponent skills. So we got our classroom example number 3. So evaluate 2 log base 8 of 512. So we still want to go ahead and do what we're doing. You can kind of take a break here. You can just look at this section here and then times it by 2 at the end is fine if you'd like. So, or we can put v here and divide this over. Either's fine. I think I'm going to divide it over just so you keep it. Sometimes people forget where it's at. So if we write it like this, we have it included. We don't have to worry about it. So in this case, it's still going to be 8. I know it looks weird, but 8 to the v over 2 equals 512. And then we got to figure out 512 to what power, okay, is, sorry, we want to get 512 to the base of 8. 8 cubed is 512. So here we are. And now we have a simple algebra problem. V over 2 equals 3. How do you get rid of the 2? We multiply. So v equals 6. So then our answer over here, we would write fully 2 log base 8 of 512 equals 6. Okay. Okay, let's try the other one here. Whenever you see these 1/overs, you're expecting a negative answer, right? Because we're going to have to push that up. So if we do this here, let's do the v. So 2 to the v equals 1/32. Now 32 does have a base of 2, but it's on the bottom. It's 2 to the 5th, so we have to make it 2 to the negative 5th because it's on the bottom. And so then v essentially equals -5, and we're done. Okay. So essentially what that is 1/32 is 2 to the negative 5th. Okay, that's what we did there for your exponent stuff. And that's what I was telling last class here, is that you really, really hope that you're doing your practice work for lessons 2 and 3. Those exponent stuff they make you do is really good practice at recognizing patterns and stuff like this in terms of your fractional and negative exponents and all that stuff that you may have forgot from actually Math 10. Okay, so this answer written is log base 2 of 1/32 equals -5. Okay, last one here. A couple things we're dealing with exponents. I know like the radicals there makes things look a little bit ugly, but I know a lot of people that just write it as 125 to the 1/2 because 1/2 is a square root as an exponent. So just kind of keep that in mind. You don't have to do that right now, but you'll probably end up wanting to see it that way later anyways. Because what's going to happen is if I write it 125 right here, I really don't know what to do with that. So I'm going to write it as 125 to the 1/2 because I know 125 can get to a base of 5. It's 5 cubed. So now you'd have 5 cubed times 1/2, which would just be, I'm just going to write it over here, 5 to the 3/2. So essentially, v is 3/2. Okay, so since v is 3/2, we can finish the answer here. Log base 5 of square root 125 equals 3/2. Okay. Very good. All right, example 4. So now this one's kind of just set up another thing you'll want to know. And we'll go and do this the long way and just figure it out. So we'll evaluate those logs up there. So we want to figure out what does log 5 to the 25 equal. Okay, because then once we figure out that equals, we can do that exponent, right? We get a number for it. So we kind of see it already. We kind of know that, I hope you do, 5 squared is 25, right? So v is 2. So that means this whole thing up here is equivalent to 2. So essentially, this is just 5 squared, which is 25. So this whole thing here, and I know that's quick, okay, I apologize, but this whole thing is equivalent to 25. Because the log 5 of 25 is 2, so now it's 2 there. 5 squared is 25. Okay, same thing over here. So it's actually the same exact one, right? Because 7 squared is 49. So you can take a second and you can just, okay, we're doing a little tedious here. So we know 7 to the v equals 49, 7 to the v equals 7 squared, so v equals 2. So up here's a 2, so it's 7 squared now. The answer is 49 for this one. Okay. I'm going to go ahead and just kind of ruin it for you in a way and stop. We know that exponentials and logs are inverses, right? So if I have a base of 5 and a log base of 5, they simply cancel. It's not a coincidence that that's the answer. Same thing here. Base of 7, log of 7, those cancel. It's not a coincidence it's 49. So let's go ahead and use that to our advantage here. 3 and a log base 3 cancel. Your answer, this one's 27. Okay, and based on your observations from A to C, what's the value of A log A of n? It's going to be n. Okay, and it's just because inverse idea, logs should cancel exponential. Okay, no different than, addition, subtraction, multiplication, division, square root. Okay, same type of things going here. Now here we have log base A of A. Will that affect anything different? Nope. These will also cancel. We'll be left with n under the same idea. The log and the exponential will cancel because they are inverses of each other. Okay? Stuff to keep in mind there as we go forward. So now what we're going to do is we're going to go ahead and step into change of base. Okay, so we have change of base. Change of base is important because your calculation, like not everything's going to come out smoothly. A lot of things we're dealing with right now, I can change the base and match them, no problem. It's not going to be that way every time. Of course, there's decimals, just like in quadratics. We can't factor everything. We have to use quadratic formula from time to time. So, for example, try to evaluate log 5 of 50. Well, they're just letting you run into the roadblock here. The roadblock is, if I do that, okay, we'll just go ahead and do it just for a second here. 5 to the v equals 50. I can't write 50 as a base of 5. Just not possible. Okay? So that means choose the correct alternative in terms of like if we're just guessing about where it's at. Well, we do know that 5 squared is 25, so that's the 2. 5 cubed is 125. So where's 50 on that line? 50 is probably right about here, closer to 2. So that's why it's probably going to be that one there would be our educated guess in terms of what we think the answer would be. Okay? Now, how do you do that? Well, I'm going to go ahead and just kind of give you that answer to that, and we're going to go over it some more. But we use change of base. And what we do is, in your calculator, whenever you hit log your calculator, automatically puts a 10 here. And that's just standard, and that's okay. But what you do is you take log of the number over log of the base of 5. Okay, so again, log of the number, 50, on top, log of the base on bottom. And these 10s, again, are automatic. That's just like square root's always a square, like as a 2, right? So log 10 of 50, log 10 of 5. So your calculator, it'll actually just look like this. The 10s won't be there. And you put that in your calculator, and it will get you that actual answer between 2 and 2.5, an actual decimal. Okay? So I kind of already went over what we're going to go over, but that's just good. So now you're ready for it. So to do this, we introduce common logs. So common logs are the log key in your calculator I talked about that use a base of 10. Okay? So for example, if your calculator, if you just did log of 1,000, well, if we do it the long way, which we learned, okay, so if we do log, I'll stay with blue, it's kind of nice. Okay, 10 to what power is 1,000? We know 1,000 is the same thing as 10 cubed. So the answer for this one would be 3. Log of 1,000 is 3. If you do it in your calculator, you're also going to get 3. Okay? Okay, so now what we're going to do is we're going to go ahead and estimate what we think these two answers are going to be, and then we're going to go ahead and put them in our calculator and see what we get. Okay? I'm going to pause the video for a second. I'm going to bring up my calculator as well, so just one second. All right, let's actually do the estimation first, and then I'll bring the calculator up. So if we estimate the value, so log 10 to 89. So all you got to do is think about 10 to what power is 89? Well, we know 10 squared is 100, so it's going to be less than 2. So, and it's going to be bigger than 1. So, if I estimated probably 1.8, would my guess. That's my estimate. Okay, we'll actually calculate here in a second. And this will go away when I bring the calculator up, so if you need to get that down, get that down. So then we have log 10, because it's a 10, right? Because of 2,000 is what that is. So that means 10 to what power is 2,000? We know 10 squared is 100. 10 cubed is 1,000. 10 to the fourth is 10,000. So it's between 3 and 4. So we go 1,000 to 10,000. So it's going to be closer to the 3 there, so I'm just going to say 3.25, just as an educated guess. Okay, and I'll pull up the calculator. I have to pause the video, and we'll do it on the calculators to show you how you put it in. Okay, so here we go ahead and we have the calculator set up here, and so we're going to do the first one there. And I told you it's log of the number over log of the base. And so in your calculator, we're going to go log 89 divided by log 10. Oh, yeah, 10, that's what it was. Hit enter. 1.94, we guess 1.8 there, so just a little bit off, but 1.94 is what you'll write right there in my blue line there. Okay, let's see if it lets me. I'm not sure if it's going to let me do it here. Yeah, it did. Okay, it's probably confused though. Okay, and then I got to take this off now. We'll do the second one. Okay, the second one is the log 2,000 divided by log 10. And 3.3, and I had 3.25 as my educated guess, so not too bad. So 3.3 would go right here, is the actual, using technology, that's what you'd get for this one. Okay, awesome. All right, moving on. We're going to talk about natural logarithms and E a bit, and just a couple examples, and we're done. Okay, so we got natural logarithms are on your calculator the ln key, and what those signify is you have a log base E. Down here at the enrichment, we're going to talk about what E is and where it comes from. But in general, log base E in your calculator is known as ln. Okay, so you don't have to write that. Okay, so just another form of a logarithm that we use. To evaluate the following logarithms, the decimal to one place when necessary. So when you do these, you can put them in your calculator. So we can go and do this in the calculator again. So let's look at ln of 5. So we got ln's right here. ln of 5. Okay, and it said log base E of 5. So we can't put the log base E in. Some of your newer calculators can, but if I do it the way I showed you, it'd be log of 5 divided by log of E. Remember, E is second division, by the way. And the other thing about E to know, and we're going to talk about in a second, is E is like pi. It has a value. It's not a variable. It has a value, so a number associated with it. And so there you see those two are the same exact thing. It's just showing the calculator is doing the base E for you. Okay, so those first two are the same. The third one, let's see what the third one here is ln of E. And what's interesting about that one, we should know what the answer is going to be on that one. It's going to be 1 because you're doing same. The base is E and the number's E. So you know that you're going to get E there for 1. Just like log 10 of 10, that's log E of E, right? So that gets you the base of 1. So that's just a little short intro to the natural logarithm, which is the ln function on your calculator. Okay? All right, cool. So let's go to the enrichment part here, talk about where E comes from. E comes from this recursive right here function of 1 plus 1 over x to the x. Okay, complete the following table, determine the function as x gets very large. So this is just approximating or showing you where E comes from. Similar to pi never ends, E is very similar. Okay, so if we come to this point here, so if we look at plugging in 10 for these x's right there, so this is a function here, putting in 10. If I put 10, you're going to get 2.5937. If I put 100, 2.7048. If I put 1,000, 2.7169, 2.7181, 2.7183, 2.7183, and so we approximate the estimate to be that 2.7183 where it kind of levels off. Okay. More accurate estimate is determined if you press E on your graph calculator. If you just push that second division, hit enter, it'll show you up to, depending on what your decimal places are, it'll show you a good number. But to 9, just so you know that it keeps going, would be about here for 9 decimal places. Okay, and so that's the E is a value. Okay, natural logarithms have E involved. Okay, good. All right. So let's go ahead and change some bases up here. Let's look at this. So this part, investigating the change of base. we've kind of already gone over this, so I'm not going to go through this all the way. All I'm going to show you is that they're telling you in this part is that when you do change a base, it doesn't matter what your base is. So for example, I can do log 25 over 5 and get ln 25 over 5, and I'll get the same thing. Okay, that's if I'm trying to evaluate log 5 of 25, right? So if I want to do that, I can do that using ln's for my common base, or just base 10 for my common base, or any base really, but those are the ones for your calculator that's easiest. And so they're just saying, when you do these two, you're going to get the same. Okay, same thing here. If I want to find log base 3 of 243, I could do log 243 over log 3, or log ln, okay, ln 243 over ln of 3, and I'll get the same. So they're just proving to you that that's the same when you're doing your common base. Okay, and what we're going to take from this is a change of base identity. As I keep saying, it doesn't have to be 10, it doesn't have to be e, it doesn't have to be anything, but it has to be the same base to do it. Okay, again, the number c always on top, the base on the bottom. Whatever base you're comparing needs to be the same. So for example, we could do 2's there. That would work. Okay. It's a little bit harder to do that one just because with the 2's, just because 2 isn't easier for your calculator. So you'd actually have to do these separate. If you want to put this in your calculator, it'd probably be this, which is a little bit redundant. On the top, over. If you want to try that one in your calculator, okay? We don't need to use that too much. You'll need to know that later for solving. It can be helpful at times, but anyways, this one here, we could do ln 1024 over ln of 4 and get the answer. If we do that for both those, you're going to get 5. Okay, the answer's going to be the same. Okay, so we're just going to practice those here. We're going to just change the base of these ones. So we got, let's just do it here, log 221. You should be following the calculator. I'm not going to go back and forth through the calculator here because they're just simple calculations. Log 221 over log 5 in your calculator. You will get 3.35. So you can see it's not a nice smooth exponent number. Okay. Log 1 over 1,000. Make sure you're putting this in. You get the brackets around the 1 over 1,000 divided by log 2. Expecting a negative here, which you get negative 9.97. Now this one here, there's a couple things you can do, but you can kind of let the 3 just hang out. You can go 3 times log 512 over log 7. And when you do that, it'll get you 9.62. Okay? That's how you use the change of base identity. Okay, so we're just on the decline here. We just have these last little 2 sections, and we will be done. I think I made the video quite a bit shorter than it was before. Okay, so convert the following logarithms to the bases indicated. So this is just a silly thing to me because it's just telling you to do change a base using the base they tell you rather than 10 or ln. So I just want you to say, just making sure that you know the pattern of log 216 over log 6, but they want these to be 3's. Because you can do that by the change of base identity. You can have that be any base you want. Okay? Now it doesn't say evaluate. The reason I say evaluate because that's not as easy to evaluate. Okay? So this one here, it's going to be log base, not 3 anymore, sorry. Log base 5 of 300. And then the one you can't see is a 10. Okay, and so that's how you put that one if you want to use a change of base identity. Okay, so find the exact value of the following. So now we're going to go ahead and figure these out. And so we are going to plug them in. So we're going to, notice it's going to say negative, so put a negative here. We're going to do log 1 over 343 over log 7. And the cool thing about this, or maybe not cool thing, but you should notice that 1 over 343, the inside is going to be negative here. So you're going to get a negative action, which is going to cause it to be positive. And when you do calculate this, you'd end up getting the answer of 3. This one's cool. We're done with this one. 216. We learned that already. 6 log 6 cancels. Okay. And this one here, we'd go log of square root 1 over 1024 over log 2. Okay. That gets you -5. And you calculate that. We expect to be negative again because of 1 over 24. Okay. All right, and this one here, we get the -5. So we're going to go, one thing you can do is, it's kind of nice, I'm going to do this without the calculator. We know 49 is 7 squared, so you can write this as log base 7 of 7 squared, which 7 squared times -5, I'll just leave that there. We don't have to do that right now. But see, we have this. So that cancels. The answer is 2 times -5. So -10 is that answer. And so doing a lot of these things, and you're probably thinking, well, you're doing those really fast. Well, that's true, but at the same time, they are that quick if you know your exponent rules. Okay, if you know your exponent stuff from, like I said, if you didn't really go through even lesson 1 very well and do all those exponent stuff to get your mind going with those exponents from math 10, then you're going to do these a lot slower and it'll be a lot more frustrating. So make sure that you're keeping up with your practice with this unit, especially. It's a big unit. Don't get too far behind. But that's all for today. Thank you.